Hey guys, how are you doing? This is Coach Scott, Coach Scott's Chemistry and Purple Wave Chemistry. So let's carry on with our moles. Okay, so we've talked about, of course, this one little formula: N equal N, capital N, the number of particles, over Na. Na being Avogadro's number. Don't want to forget that. 6.02 times 10 to the 23rd. All right, of things. Now, let's think about that, okay? So that's things. It could be a salt formula unit. Let's do CaCl2. That's a good salt. Okay, calcium chloride. We've been using a lot of that. Another salt or a molecule. Let's use sugar. C6 glucose, H12O6. So if I have a mole of calcium chloride, that means I have 6.02 times 10 to the 23rd formula units of calcium chloride, okay? So if I ask how many calcium ions I have, well, then I have 1 mole in that 1 mole of calcium chloride because it's Ca. If I say, and this is just like the omelets, if I have 1 mole of calcium chloride, that means that I have 2 moles of chlorine ions, okay? Chlorine ions. So those are the formula units, okay? Now this sugar, it's a molecule, okay? You've got covalent bonds. They're sharing electrons. Remember that. So if I have 1 mole of sugar, that means I have 6.02 times 10 to the 23rd molecules of glucose, C6H12O6. So how many carbon atoms do I have in a mole of glucose? Well, then I will have 6 times 6.02 times 10 to the 23rd atoms. How many atoms of hydrogen? 12 times 6.02 times 10 to the 23rd. If I have 1 mole. If I have 1 mole of glucose, that means I have 6 moles of oxygen atoms. Okay, so these are great, but I have no way really to count the particles. The particles are what we worried about with moles. So what's one way to do it? Oh, I know. We can weigh them if we had a way to do it. We do. It's called the gram molecular weight or the gram formula weight for each atom, each molecule. We did a little bit of this, but we're going to do more. And where do we get the gram formula weight or the gram molecular weight? From our periodic table. Okay, so we have our periodic table, our most important tool in our toolbox that I've given you this year. So let's just see something here really quick. Let me get my little calculator out. I got my TI Inspire. I'm ready now. Okay, so what would be the gram formula weight for calcium chloride? Okay, and again, I'm going to find from my periodic table the AMU weight, which is the weight or mass in AMUs of 1 formula unit of calcium chloride. So calcium has a atomic mass of 40.078. Okay, AMU. All right, chlorine has a formula mass. Let's use another one. Has a formula mass of 35. Chlorine is 35.545. You want to be exact. And there's 2 of those. So that's be times 2. So that would give me the formula mass, if you would, All right, 35.45. Calculate 35.45 times 2 plus 40.078. Okay, so that gives me 110.978. All right, so we'll say that that is 110 point, well, we go for now, I'll just say 978. Okay, and that's in atomic mass units. If I have this many, and if I did the math, and I don't really want to do that, just trust me that this can be the gram molecular weight. We can just magically say, okay, or this is now 110.978 grams per mole. It works. So if I say I have 60 grams, okay, ooh, we got a new formula here. I'm going to put it up here. So if I want to find the number of moles I have, and I have a mass, which I can weigh in the lab, and I have a mass of calcium chloride, right? And my mass, when I put it on my scale, my balance, it says I have 60.31 grams of calcium chloride. So that's what we're going to call M, our mass. Now our molecular mass for calcium chloride would be down there. So our molecular mass, that's a capital, big capital M, is our molar mass. Our molar mass would be here. That's our molar mass. So in order to get the number of moles that I have, I'm going to divide the mass of the sample times this, the molar mass, okay? So let's see what it is. 60.31 grams divided by 110.978. And then I'm going to use the right number of sig figs. That tells me that my moles of calcium chloride down there is 0.54. I'm going to only use 2 sig figs because of that. 0.54 moles of calcium chloride. So that formula, we've got this one here, is N equals M for the sample mass divided by M, capital M, for the molar mass. And where do we get the molar mass? Periodic table. It's the only place we get it. All right, so I'm going to take a slight break. Then we're going to talk about our volumes. How would we find the number of moles, if we have a volume of gas? It only works for gas. So I'll be here. I'm going to erase this board and come right back to you. So, hey guys, how you doing? Coach Scott again, Purple Wave Chemistry. Let's talk quickly about what if we talked a little bit about molar mass. How about volume? So to find moles for volume, it only works for the gases. We'll find more when we go through the unit on gases, but think about a gas. You got all these particles. So if you have an ideal gas, okay, and we'll find out why this works here in a bit. For right now, just trust me. If I have 1 mole of any gas at standard temperature, which is 0 degrees C, 273 K, and 1 atmosphere or 760 torr or 101 point whatever kilopascals, standard pressure, I have exactly 22.4 liters of gas per mole. Okay, so we call that the molar volume. It doesn't matter what the gas is. It could be air, it could be nitrogen gas, it could be whatever. All right. So that's how many liters of gas are in 1 mole. So we can write I did a capital. I don't want a capital. I want just little n for the number of moles is equal to what? Whatever your volume is divided by the molar volume of 22.4 liters per mole. So we have a new formula, which is similar to our other formula. N equals what? The number of particles over Avogadro's number, 6.02 times 10 to the 23rd. And we previously we figured out about molar mass. Let's see what that one was. So molar mass is, to find the number of moles, is we take our mass of whatever substance we have, and then we divide it by the molar mass of that particular sample, whatever it may be. And where do we get molar mass from? The periodic table. And we have to add up the individual masses, all right, in grams per mole, or AMU for that matter, but grams per mole to find the number of moles, okay? So we're going to use that as a big capital bold M. So we've got a little something here. All this equals the number of moles. So now we can draw something a little bit more cooler. So to find N, depending on what we're trying to do, N, if we have volume, the amount of moles we have is whatever our volume amount is, our sample volume, divided by the molar volume, which is 22.4 liters per mole. Okay, so if we have mass, right? All right. Then the number of moles is equal to our sample mass divided by the molar mass, which we get from the periodic table. Depends on whatever substance we're looking at. And our last relationship, I'm going to make like a little something like this, is if we have particles, atoms, molecules, golf ball, whatever, all right? So the number of moles of particles is equal to the particle sample divided by Avogadro's number, like that. So now we have a way to find the number of moles from volume, from particles, and from mass, okay? So let's make it simple. We can memorize all that stuff, or just know if we're going to find moles, right? The number of moles, then we divide, right, by the molar volume. Okay. If we need to find particles, then we multiply the particles, right? The particles by the number of moles. If we need to find the particles, then we're going to multiply the molar mass times Avogadro's number. And if we need to find the amount of the sample mass, then we're going to multiply the number of moles by the molar mass. All right? So to find moles, divide. To find the individual particles, volume, mass, multiply. So whatever works for you, do it, okay? I'm going to write that down. To find moles, multiply. To find mass, sample mass, I'm going to do that. Our volume, our particles. Then I got that backwards. Find moles, we divide. correction, divide. Defines sample mass, volume, or particles. We multiply. Okay, that's it. So we'll do samples, and I'll probably do videos where I do some of these problems so we can see what we're talking about. So anyway, let's